So what we're going to do today is we're going to work on a lab which is going to illustrate Pascal's principle, and I'm just going to kind of walk you through, since you probably don't have these around your house, and if you do, you probably have someone who's in the medical community at your house. These are syringes, and I've got two syringes that are locked together, and we're going to use these to help illustrate Pascal's principle here. Okay, so I'm on step number 1 on your sheet, and I've locked these syringes together so that there's 3 milliliters of volume in this narrow cylinder here. Okay, and there's 0 in the larger cylinder. And what I'm going to do here is I'm going to press this small cylinder down to 0. Okay, but when I do this, if I look at number 2, I want to know how many centimeters that is traveling down, and it looks like it's going to be traveling down about 5 centimeters. So that will be your answer to number 2 on your sheet. So I'm going to do that. And you'll notice that when I do that, I'm going to work back here. When I do that, this larger plunger is actually going to move in its own right. Okay? So, if I look at number 3, what was the change in volume in my small cylinder? Well, I started at 3 milliliters, and I went to 0. So you should be able to calculate on number 3 what the change in volume was. Question number 4, how far does the large cylinder go up in volume? Well, if I look here, 1, 2, 3 milliliters. Okay? If this went down 3 milliliters, this went up 3 milliliters. That's pretty easy to figure out. That's number 4. So, question number 5, how do 3 and 4 compare to one another? You should be able to figure that out. Question number 6, how far did this go up in distance? Okay, this one went down about 5 centimeters. This one went up about 1 centimeter, if you can see that. Went up about 1 centimeter. So that is my answer to number 6. Number 7, I'm going to plunge this all the way back down to get it to its initial position. So when I do that, that's what I'm going to get there. It just needs to kind of squeeze a little bit more there. And now I'm on to the next page. Okay, which plunger is easier to push down? Now when I do this, it should be fairly obvious. I actually have to work not very hard at all to push this small plunger, and that goes up relatively easily, but I have to actually exert a lot more force on this to get this one to move. So less force on this one, more force on this one, and that is because of Pascal's principle. If I increase my area, then this is going to have more force, this is going to be less force. This is a principle under which hydraulics work. Okay? So now let's zip down. You should be able to figure out number 8 based upon what we've done. Okay, I've misnumbered things a little bit here. But if I'm on number 10, what is the cross-sectional area of the interior of the large syringe? So my equation for area is 3.14, which is pi, times r squared. Now the radius is half the diameter. So the diameter of this is about 2.2 centimeters. That means that the radius is 1.1 centimeter. You're going to need that to help you calculate number 10. On number 11, what's the cross-sectional area of the small syringe? Well, the diameter here is about 1. That means that the radius is 0.5. So you're going to use 0.5 centimeters to help you calculate number 11. And you should be able to figure out 10 and 12 what that answer is. And based upon Pascal's principle, you should be able to calculate number 13. Now, if you look at number 14, what have we sacrificed in order to increase our force? Well, here I have to press this small plunger a long way to get this to go just a little distance. If I go this way, I push this a small distance, and this goes a larger distance. So there's a big difference. I have to sacrifice this much more distance, but it's worth it because I'm increasing my force. Now, if I were to try a second setup here, I'm now on number 15. If I were to try a second setup where I have this much larger syringe and this much smaller syringe, let's compare that with the first situation. I have a larger syringe on this side and a smaller syringe on this side. So what do you think is going to happen here out of my options on number 15? Will it be harder or easier to push these back and forth here? Okay, so those are questions you have to ask yourself. Okay, think about Pascal's principle. What is going to be true here with this situation? So that is the lab that you are going to try, and those are how you're going to get the data for the lab, and they should make sense because you've already done the simulations related to that lab. Use those numbers to help you calculate it, and I'll be around to help you out. We'll see you soon.